care about those operations or care about the systems after you release it. Because when we were students, all we need to do, all we need to care is before the, let's say, the final presentation, we finish those code, and then we can do the demo. And after the final presentation, everything is done. We don't need to operate that, and then we don't need to care about those maintenance anymore. However, in the real world industry, this idea and then this term is very important and very practical. Now, I think for students, it's better to know it as soon as possible when you're still students. And then after that, the second part will be site reliability engineering. Actually, it's kind of the same things, but we say that site reliability engineering implements DevOps concept. So DevOps concept is overall is a higher idea, and then the site reliability engineering is more practical and it tells you exactly and then in more detail that how you are going to implement those best practice. And then after that, the third part will be the sharing and then my engineer career in Japan. Actually, the third part will be the most important part, and then it lasts longer than the previous two parts. Anyway, now for Taiwanese engineers, there is a trend to go overseas, to work overseas. And then I think maybe not many students, not many people think Japan is an option, but actually it is. So that's why I would like to come back and then to share with the students, and then that actually Japan is one of the options you can consider when you want to work overseas. Okay, so let's go. This DevOps cycle is very famous. So anyway, in a company, when you want to create, when you want to work on some new feature or new project, new service, you will go through these phases. In the development phase, you will go to plan, and then after planning, you have those requirements, and then you go to code. And then the code, you will build your code. For example, you use Java, and then use Maven, and then you build your artifacts. And then the testing phase will need to be done. And after all those testing phase finished, finally you can release that to your end users. And then you deploy your application. And then after that, that application will always be online, and then it's alive. Then you need to operate it. And then you will also have a monitoring stack, monitoring technique to constantly check your service healthiness. And then it's this kind of phase needs to be done for every new application or even every new small feature. Okay. However, in a bit like several years ago, this kind of phase and then the time for the company to go through all these phases are actually very long. It's considered to be like waterfall practice, that in a company, then all these phases maybe are done by different teams. For example, you will have an individual testing team to do all those QA things, and then after your development, you will have a independent unit. You have an individual operation team to operate that service. So actually, in the companies that doesn't adopt DevOps concept, that still using more waterfall practice, then this phase and then this loop takes a long time. Okay. And then however, in these recent years, some of the very important trends in our industry come out. Those are they are these kind of things. I would like to explain one by one. So for the first thing is microservices. In the past, that we like to make a very big application. It's called monolithic application. That means maybe your front end, your back end is tightly coupled, and then so all engineers, they work on this very big application, and then on this very big repository, and then so in that case, actually you cannot move very fast. And then there's a recent trend that is called microservices, and then that is we separate this kind of big application into different small microservices, and then they will interact and then calling each other, and then so that your entire application can serve its functionality. And then the second trend is called Agile and then Scrum. Actually, Agile and the DevOps is kind of the same idea, but Agile is more towards like team management and then toward business values that you want your whole software development to be faster. And then a DevOps idea is more towards engineering. So anyway, they are the same, that because as I explained, that if you go through the waterfall and then if you have a lot of independent teams to be responsible for each phase, then actually it takes a long time for a new feature from development to release. That takes a long time. And then now the trend in the industry is that we want to be more agile. We want this feature to be unreleased sooner than before. And that's the idea of agile development. And then the third one is container technology. So container compared with VM, with virtual machine, actually it's a more lightweight way to run your application, and then its cost is lesser. And then so because I think you probably have heard about those Docker technology, and then because of the matureness of the container technology, now we can really make your microservice into container. So they are all related. And then the fourth one is container orchestration tool. After the container technology becomes more and more mature, ready for the industry to adopt, then we will need to have some orchestration tool. That means the tool to really to manage and then to try to monitor those containers, because for a big company, maybe you will have tens of thousands or even more than that containers at the same time, and then you will need to have a tool to manage that. And also, like, luckily that we have Google to open source Kubernetes as I think it's the most most popular container orchestration tool now in the industry. So it's like considered to be industry ready, and then when we want to use container orchestration tool, we always would like to adopt Kubernetes. And then another trend is called infrastructure as code. That means for any like configuration, for any like environment, for any deployment, and also for your pipeline, you all need to commit those things into Git, and then those your like pipeline, your how to set up your application and then how to run your application, those all need to be written as code, and then those code needs to be checked into Git repository. So this concept is also very important nowadays. And then the CI/CD pipeline. CI means continuous integration, and the CD means continuous delivery. So anyway, because a new code, a new feature needs to go into several phases in order to go to the final release, and then we will need to have a pipeline, and then for those new code to be automatically go through those phases, and finally can go to release. So this pipeline is also very important. And then there's another word called cloud native. So anyway, if your application can fit, your application satisfies those conditions as I just explained above, and then there are also of course some other conditions you need to satisfy, then your application can be considered to be cloud native. So anyway, your application can be easily scaled out by maybe Kubernetes, or maybe by some public cloud like AWS or Google Cloud, and then your application can be said that it's cloud native, and it's very important in terms of your company's moving fast. So in terms of your company's speed. Okay, so all these trends are very important now in the software industry. But when I was a student, actually, I didn't know these things. Is there any question? Oh, okay. And then I would like to explain a little bit more about CI/CD pipeline. So, as I say, that for a new commit, for a new feature, for a new snippet of code, you need to go through these phases, and then in order to go production. So from the code commit, then you commit your code into Git, and then this logo in the center is the logo of Jenkins, a very popular open source like the pipeline tool. So anyway, this Jenkins tool is like the controller. It's like the main character in this pipeline. It controls all these phases. And then so after your code commits to Git, and then Jenkins can automatically detect that, okay, there's a new PR. And then that PR will go to these phases. You will build your artifact, and then maybe your artifact will be sent to some auto testing machines, or at least do some unit test, and go to this testing phase. And then after the testing phase is finished, maybe it can be auto deployed to your staging environment, and there you further do more testing, and then at the end you can go production. So this pipeline, anyway, as you can imagine, that in a big company, maybe different people or different team will be in charge in different phases. And so anyway, for your code to go production, you need to go through these phases, go through this pipeline, and then we need some tool to automate all these things to have higher efficiency. So this Jenkins is one kind of a pipeline tool. Okay, so as I explained that for a new feature to go production, you will need to go through all these phases. But if your company use a more like waterfall way to do the development, these phases take a long time. And then so a recent, not very recent, actually 10 years ago, that I think Yahoo engineer proposed that, okay, actually, your team should do all these things by yourself. That means your team actually should do development, and then also you have a QA tester, and then after you release your application, release your service, then you also need to do those operation. That means you need to maintain it's healthy, and then maintain that service, and then also you need to do those monitoring, like all within one team, and then that team will go through a faster pace. And then so anyway, to combine the concept of dev and ops together into like one team, and then make them we want to break up the wall. We want to break the wall between dev and ops. Then that is the idea of DevOps. And then if we can achieve that, actually the efficiency and then the speed can be better to deploy your new feature. So that's the concept of DevOps. And then in order to achieve that concept, to break the wall between dev and ops, to combine them together, and then to increase your speed to deploy your new feature, we need to have a lot of tools to help us in different phases. Because as I said, okay, you will go through these phases, and then you need to have some automation tools, and then anyway, in different phases, we have so many tools. From the code part, you can see that we have Git, and then Jira, the ticket and complaints. And then in the testing, we at least do the unit test. And then for the release, in the release phase, we have Jenkins, as I explained, is the pipeline, like the controller, is the center row. And then for a deploy, we have like Docker, and then for operation, we have Chef, Ansible, Kubernetes, and the monitor, we have all this Datadog. So Anyway, I just showed a lot of tools, and then they are widely used, and then of course for different companies they use different tools. However, those are just too much, right? But as a senpai, as a senior engineer, I mean, I can give some suggestions to the students now that at least I think you can try to get familiar with these tools. The first one is Git. I think everyone is using Git here, right? So anyway, Git. And then the second one will be Docker. Docker is a container like format, and then also it has its engine, like it's the container runtime. Anyway, I think as far as I know that now for a lot of applications, it provides a Docker image. It provides a way to run those applications by using Docker command. So at least I think I suggest you that from now on, if you see some, okay, I want to use some library or I want to use some open source service, and then they provide a way to run that application by Docker, then you can try to use that. At least you get familiar with those Docker environment and how to run those Docker commands. This is very widely used in the industry. And then also, if you can take a look at the Docker file, I mean those format, and then at least you understand its layer concept, something like that. So anyway, the second one is Docker. And the third one is Ansible. Actually, Ansible is just, it provides its YAML, Y-A-M-L format, and then they also provide their syntax that you can do many automation things. For example, if you want to access your servers by SSH, and then after that you want to log into those servers and do something, then you can use Ansible to do that, and Ansible provides their syntax, as I say. Then you don't need to write code, you just write the Ansible syntax, Ansible configuration, and Ansible will do the things for you. So this one is also some tool, and then you can understand it, you try to understand, and you can try to use. And then the fourth one is Jenkins. Okay, Jenkins I already explained, but maybe Jenkins is not that easy to use because you need to set up the Jenkins server, and then you can use Jenkins and then to build those pipelines. But anyway, Jenkins is very popular and then very easy to use it. So if you have chance as a student, you can still play with it. And then the next thing is Kubernetes. Kubernetes, as I explained, is the most popular and then mostly adopted container orchestration tool now in the industry. And then if you want to host your application, maybe you can consider to use Kubernetes and then host it. So, for example, in your final presentation, maybe you can try to make your application in a Docker file, and then you set up the Kubernetes environment, and then you host your application on Kubernetes and then demo to other students. Maybe that's a choice you can choose, and then you are going to learn a lot from that. Okay, so anyway, today the first part, my intention is just to want you to have at least some basic understanding of DevOps, and then hopefully in the future, when you are still students in some projects, you can try to use these things, and then so it's going to help you in the interview. So, for example, if I'm an interviewer and then I know that you have some kind of understanding of the pipeline, and then understanding of how the real world developed the software, then I'll be very amazed by your performance. Anyway, okay, this is the first part. And then the second part will be site reliability engineering. So as I explained in the introduction, that actually site reliability engineering is just like a more detailed implementation. So now we think that actually site reliability engineering implements DevOps. DevOps is more like abstract, and then site reliability engineering is more concrete. And then this thing is actually it's a book released by Google. So you can just search on Google site reliability engineering and PDF, something like that, and then you can find that book. And then this book is like one of the Bibles in the DevOps in the DevOps field now, and also of course in the site reliability engineering, because this term is coined by Google. Anyway, in this book, it talks about a lot of things to how to maintain your site reliability. That means how to make your service, how to make your site always have very high availability, always have very high dependability, and reliability. Anyway, so there are some chapters like SLA, SLO. SLA means Service Level Agreement. Anyway, and then also including toil management. Toil means routine work. In this book, it says that, okay, for site reliability engineer, at least you should spend more than 50% of your time working on those development, working on new features to decrease your operation cost. So your operation costs should not take more than 50% of your time, something like that. And then also it has the monitoring chapter, release engineering chapter, on-call policy, and then postmortem culture. Postmortem means after some outage happens, then how do you deal with that situation, and then how you can have a meeting and then to discuss those outage, but in a very polite and in a very practical way, no finger pointing. So anyway, these are just part of this book, Site Reliability Engineering, and I'm not going to go any further, go into any detail of these books, because maybe this book can be a course that lasts the whole semester. It's too much content. But I just want to also tell you that you, in your free time, you can also download this book and then to read it. It has 400 pages. If you can finish reading this book, actually you are already better than me, because I haven't finished reading this book. So anyway, this is a very good book that I recommend the students can read. Okay, so those are the two parts of the speech. So I'm going to talk about the engineer career in Japan. Okay. So now there are many Taiwanese students, Taiwanese engineers going to work overseas, and then, for example, many students go to United States and then they study a master degree, and after that they just stay in the United States and they work there, right? We have many friends doing the same thing. But is it really a good thing? I mean, so before telling my story about working overseas, I would like to ask this question, and I would like to answer this question. Is working overseas good? And then what is the pros and cons of working in another country, not in Taiwan? Okay, so is it good? We can separate it into two parts. One is for individual, for yourself, or the other part is for Taiwan. Okay, so for individual, I think basically it's good. And then these are the advantages, these are the merits. The first one is because you work in another country, you work with foreigners, not working with Taiwanese. And then actually in that kind of working environment, you need to have better soft skill, because different people think differently, and then when you cooperate with them, you need maybe better communication skill, and then sometimes you'll feel that why do you work in this way, and however it's just their country, or it's just the way they do it, and then so you need to accept it and then try to find a good way so that you can have better output for the team, something like that. And then so in a way your soft skill will increase, so that's a good thing. And then the second thing, I already said that because you get to know other countries' people, and then basically I think your mindset will be wider, broader, and then you can easily learn to think from another point of view, then that actually makes you a better person. And then the third thing is enrich your life experience. That means not only at work, in your after work, in your leisure time, you can also have other life experience. For example, I work in Japan, and then I can very easily go snowboarding in winter, and that's not a thing that we can do in Taiwan, right? And there are also other kind of like entertainment in Japan, and then so to me, at least, I think it makes my life more like having more experiences than I can have in Taiwan. And then so that's, to me, I think it's a good thing. And then the fourth one is improve ability when preparing. That means, okay, now if you want to work in another country, at least you need to prepare, right? Before that, you need to prepare. And then I think in the process, actually you improve your ability. You try to maybe study English, or you try to study algorithm, practice on LeetCode, something like that, and then your ability actually improves. That's also a good thing. And the fifth thing is higher salary. So this one is actually not a guarantee, but it's a general thing. If you can work in other country, in USA, in Singapore, or in Japan, basically you have higher salary. Otherwise, you will not go there, right? And then the last one is more choices make your life better. So to me, I personally believe that if you have more choices, then your life is actually, better. And then that means we are Taiwanese, and then we always have a choice, that is to work in Taiwan. And then so now if you have another choice, that is work in another country, so that means, okay, now I have more choices, right? I can decide to work in Taiwan or to work overseas. So when I have more choices, multiple choices, I feel like my life quality is better. So anyway, I would like to make myself a person who always have many choices. Okay, so this is also advantage. Okay, so I just finished that. So now at least to individual, okay, it seems that working overseas are all good. It's always good, all advantages. But to Taiwan, is it a good thing? The first part is, I think that's kind of a bad thing. That is the GDP and then the consumption. Our purchasement, something, all our activities are not in Taiwan, right? And then so the Taiwan's economy may be worse in such a situation. So that is not a good thing to Taiwan. However, there is still some other advantages. The first one is this one's also like improving ability when preparing. That means, okay, I think if I increase many students who work overseas, and then they will need to prepare, and then so their ability, their talents also becomes better, and then so I think overall to Taiwan is a good thing. And then the second advantage is bring resource back to Taiwan. Actually, there are some famous people, as I cited here, that Mr. Du Yijin, Zai Benqiao, Zhang Zhongmo, they actually worked overseas when they were young, and then they learned, and then they cultivated, and then they got a lot of resource in those big companies in another country, and then somehow when they become more senior, they think that, oh, it's time for them to do something in Taiwan. They want to contribute to Taiwan, and then they come back to Taiwan, and then at the same time they bring some resource. For example, Du Yijin, he was working in Microsoft Asia or something, AI lab, right? And then he come back and then established AI 研究室 AI 新创研究室. And then Zai Benqiao was working in Google, and then he comes back and then to set up another company. Okay, even though the company is not. Okay, and then the third one is set up organization overseas. Okay, this one is the Japan's example. In Japan, my friends, they set up a organization. It's called Japan Insider. It helps Taiwanese company to do crowdfunding in Japan. So that means it helps Taiwanese company to try to earn Japanese money, and then so in this way, I think it's a good thing, right? Because it helps the Taiwanese company to step out from Taiwan and then try to earn other countries' money. So that's a good thing if you can really set up those organizations and then try to still have some connection with Taiwan. And then the fourth thing is introducing trends in other countries back to Taiwan. This one is also a community that I'm in. It's called Work Life in Japan. It's actually a blog, a media, and then in that blog, and then there are many authors, writers that write some articles, and then to introduce Japan's trends or Japan's thoughts back to Taiwan. So if some people in Taiwan they see these kind of articles, and then they can come out with a better solution or better decision, then I think it's also good to Taiwan. So anyway, my conclusion toward this question that is it good to work overseas is my conclusion, my answer is basically I encourage that because it's good to individual, and then however I want that if you work overseas one day you still actively connect Taiwan. That means, or even though you are overseas, but you still can do something to Taiwan, like what I'm doing. For I write some articles in Suez Day, and then that's what I want to share, like Japan's story, Japan's example back to Taiwan, and maybe Taiwan's some companies they can reference that, something like that, or like this time I come back to attend the DevOps Days Taipei. That I also introduced Japan's tech practice back to Taiwan, something like that. So basically, I encourage everyone to work overseas. However, it's better for you to remember that keep actively connecting to Taiwan. Okay, and then this one is my article. So if you want to read more about this issue, this question, I also have the answer written in this article. Okay, so after answering this question, I'm going to introduce the job trend in Japan's IT industry. So anyway, this is just a survey showing that Taiwan and Japan are in lack of the IT talents. Okay, for example, you can see engineers and IT are in the second and third rank of those in-demand roles. So they are in deficit. They are required a lot. However, Japan and Taiwan, they have no enough IT talents. And then this one is also showing the same trend. Okay, this picture was showing the Taiwan's trend, and then this one is showing the Japan's trend. Anyway, Japan now is lacking of is lacking of IT engineers. So what is the reason for that? The first one is overall industry demand increases. So actually the software engineer boom, software engineer demand is a worldwide situation. That means in every country actually they feel that they need more IT, they need more software engineers, and then so anyway, it's a worldwide phenomenon. It's not just in Japan. And then the second reason is IT technology updates pretty fast. I think, for example, in front end, maybe several years ago, we were still using jQuery or something like that, and then now we are using Vue.js, we're using React.js, and then so if you cannot follow the trend, that means those old IT guys or IT workers, they will be kind of eliminated, and then however we still have new demand, and then however new technology keeps coming out, and then we will need some new people who knows the new technology, and then so that's a demand, and that's always because in our industry this kind of speed, this kind of update speed is very fast. and then we always need new talents, new people who knows the new technology, and then that's a very big demand. And then the third one is salary is not relatively high. That's the situation in Japan. That means in Japan, actually, how can I say, engineering students compared with non-engineering students, their salary is not higher a lot. I explain in Chinese a bit here. 就是说在日本，如果你是念文科的话，其实你的薪水跟理科跟这种工程不会差太多。那这在台湾就比较不一样，因为大家知道，在台湾可能如果你念文科的话，起薪会比较低，但是在日本没有这种情况。Okay, so salary is not relatively high if you study computer science, if you become software engineer in Japan. So students in Japan, they don't really want to go to study computer science. They want to go to finance, they want to be consultant, and then they want to go to 商社 business company, something like that, and then they don't want to study computer science and become software engineer. So their students are not that many, and their demand is higher than their demand is higher than their supply. Okay, and then the first reason is IT engineers have bad working environment. In Japan, it has a impression. It's called 3K. 3K anyway means very hard working environment, and then that's another reason that why Japanese students don't want to go into software industry. And then the fifth reason is Japan population decreases. So anyway, now all the problems in Japan can be due to this reason. I mean, Japan's population is now decreasing. And then, so anyway, it's these reasons make that Japan's IT talents are not enough. They are in big demand to recruit software engineers. Okay, so this link is also an article I write. If you want to understand more in Chinese, you can read this one. Okay, so anyway, the conclusion is in Japan now, IT software engineers, the demand is very high. Okay, so now we know that the demand is very high. That means we have chance to go to work in Japan as a software engineer. But is it a really good working environment, or what I just explained, the stereotype, the image, was it correct? So later I'm going to explain these things, the IT company and the working environment in Japan. And I will also answer, is Japan's IT technology good or bad? And also I will explain what does it mean, a programmer or a software engineer in Japan. Okay, this picture is maybe a Taiwan software engineer that okay, anyway, just see this manga. And then, so in Taiwan, maybe if you are a software engineer, you probably